Hello and welcome to this video series on using Python programming language, specifically with the Spyder interface. This is video 1 of a 3-part series. Python is an easy-to-learn, powerful programming language. It has efficient high-level data structures and a simple but effective approach to object-oriented programming. It is used for readability and productivity. We're going to discuss what is Python and what is Spyder. We're going to download Python and Spyder, talk about the Python and Spyder environment, edit and recode data, runs different statistical tests, and create some visualizations. Specifically in this first video, we're going to provide an overview of the scenario, discuss what is Python and Spyder, how to download Python and Spyder, discuss what a module is and how to install them, provide an overview of the Spyder environment, provide foundations of the Python language, and create objects. So in our scenario, we're interested in studying the relationship between the amount of corruption in a country and the quality of their economy. For this question, we're lucky that data already exists. We'll be using the World Development Indicators, or WDI dataset, which is compiled annually by the World Bank. We're using data from a previous year and have simplified the dataset, but you can find the full dataset at the World Bank website. We're also lucky because World Bank saves the data in a way that makes it easy to open and run, compared to other datasets like old census data, which can take a lot of effort to transform the data into a usable format. And of course, there's never a guarantee that someone else has created a dataset that you want in advance, so the first step in any research project is to spend a lot of time thinking about the values and variables that are needed for the data you want to use. Within the WDI dataset, we'll be focusing on 2 variables. We'll be focusing on corrupt and GDPPC. Corrupt is an index of perceived corruption within a country's government. We'll be using aggregate level or country level data. However, within each country, citizens were surveyed and asked questions like, would you need to plan bribes to start a local business? Note that corrupt is reverse coded, so that higher scores equal lower corruption in ranges from 0 to 10. The second variable is gross domestic product per capita, or GDPPC, which indicates how well the economy is doing scaled for the population size of a country. For example, it might not be very interesting to note that Botswana produces less than Brazil overall, but it might be interesting to note that Botswana produces more per citizen than Brazil in 2014. Note that in using the variables from the WDI dataset, we have given over the responsibility of the operations of corruption and quality economy to the World Bank. Therefore, we might have a different operation of these, but we are stuck with what we have. We have also allowed dynamic concepts to become simple numbers. However, this allows us to move quickly into the later stages of analysis, which has its advantages. So a little bit about Python. We're going to be using Python 3. Python is an object-oriented language, meaning everything is stored in the computer in the program as an object. An object could be a single value, it could be a number, it could be a floating number, which is a number with decimals, it could be a list, it could be a dictionary, it could be a data set. So it's an object-oriented. You can have multiple data sets open and have different subsets all within the same environment. Python is also 100% free. If you're interested in downloading Python Anaconda, which is a really nice distribution, you can go type in Python Anaconda into search or an internet browser. You want to download the individual edition. Go ahead and download it, and it'll direct you to what OS you're running and download the corresponding one. Anaconda comes built in with the Spyder interface, which makes it easy to run the code compared to other interfaces. It also has thousands of different modules. So think of a module as a toolbox filled with different functions. These different functions make it easier to work with the data, from everything of importing different types of data to different cleaning, to different types of analyses, as well as things like TensorFlow for machine learning. So all of this comes in really handy. Get rid of that old code there. So what I'm going to do now is, right now I actually have the Spyder interface open. This panel here on the left-hand side, this is where all of our code is going to be. We have our console window, which has 3 tabs. We have a help tab, variable explorer, which is going to list all the variables or all the objects in your session, and a file explorer, so you can actually figure out what files to pull in. We're going to do everything through syntax though. Then we have the IPython console. in is just showing an input cell, and there's going to be a corresponding output cell when we run this. Now I have the Python script already installed on, or already downloaded onto my desktop along with the dataset. So I'm going to go ahead and open that up. So I'm using Python workshop.py. A .py is just saying it's a Python script. Everything with the pound symbol is essentially saying this is a comment. I'm a big fan of annotating code. This way it makes it easier for others to read it, and also as a reminder for myself of what I'm doing. It is critical, though, whenever you run Python code, to make sure that any modules that you want to have active and to use should be at the top of your code. This allows them to become active. So rather than running things here for now, I'm going to show you a couple of different things with the modules. So there's a lot of different modules we'll be using today. Some of them we actually won't be using. We actually won't be using NumPy or the mode function from statistics. That's why we have this code analysis saying it's imported but not used. These are just as examples. We're going to first be using Pandas, which is not the cute fluffy animal. It's actually going to be used for panel data, is what it stands for. It is an open source BSD licensed library, providing high performance, easy to use data structures and data analysis tools for Python. It can take common data files such as CSV and Excel and import them into Python. And it has a lot of really handy different features and functions to make it easier for data cleaning. So in our console window, I'm going to go ahead and type out import pandas as PD. So when we reference any function from the pandas, rather than having to spell out pandas, I'm now using a shortcut referring to it as PD. I can go ahead and check what version. So PD dot, and then 2 underscores, version 2 underscores, and that's saying return which version of pandas that I'm using. Now there are many other options that can be used when loading in data files such as CSV and Excel, and please refer to the help documentations. You can also pull up documentations by typing in help. When you use the function of help, pd dot read underscore CSV. That's going to pull up the information related to the read underscore CSV function from Pandas. And that pulls up the information on it. You can also open up an Internet Explorer or Google or Firefox, type in Pandas and the function, and that will also pull up the documentation too. Now, straight out of the box, the Python functions are limited. However, these many libraries, sometimes packages, sometimes called modules, are available to users to make it much easier to work with. Some popular packages are NumPy for math and scientific computing. We have Pandas, which we talked about for data structures manipulation. There's scipy.stats for scientific computing. matplotlib.pyplot, which is for data visualizations, as well as Seaborn, which is another package, as well as stats model for regression. So we'll be using stats model formula.api and importing the OLS feature for multiple regression. So for this tutorial, we actually have to first import the OS package, which is for operating systems, to then change our directory, kind of pointing to, for Python, where we should be working out of. Right now, we're just in the eSchuler folder based on this. So I'm going to go ahead. You can do this a couple of ways. If you're running single lines, you can highlight and then click this button here to run it, or have your cursor at the end of it, and that'll do the same thing. So right now, we've imported the OS module. We've done an OS, and the specific function from that is change directory, and then specifying the path. You can also change your path here, and then going ahead and changing it around too, but if you do that, do not run these lines of code. It will throw an error. So I'm going to go ahead, I'm going to import NumPy, Pandas, SciPy, matplotlib, and some different statistics functions. So now we're going to talk a little bit about some Python basics. Again, everything after this pound symbol is going to be a comment, and Python will skip that. So we talked a little bit about how everything is an object. We're going to create a couple of different objects now. We're first going to create an object called D and assign a numerical value or an integer of 4 to it. So we're saying creating the object and saying what it's equal to, and then 4. So when we run line 24, we now have an object called D. The type of variable is an integer. The size, it's only one value in there, and that value is 4. We're now on the variable explorer here to see that. If you run 25, simply calling the object, that's going to print out the value corresponding with the object in the console window. We can also assign a floating number. So we're going to create an object called E and assign it 3.14. Now, a floating number is like an integer, however, it has decimal points. So when we run that, we now have a floating number, or floating object called E, and the value is 3.14. And when we go ahead and call that, so running line 29, that goes ahead and prints it out here. We can, now I do want to mention that Python is cap sensitive. If I was to do a capital E, it's going to say it's undefined and throw an error message. So I'm going to create an object called X, and we're going to create a list. So a list, you start with the object equals for the assignment, then you use square brackets and list all the values separated by commas. When we run that, we have an object called X, it's a list. There's 10 values within this, and we can see those here. Now, a list is very flexible. It can be numbers and strings and most Python format types. It also allows for duplicates. In addition, the list is elemented, the list is ordered, and it can be changed. So if we do print, so right now we're going to do a couple of different methods or functions. We're doing a function within a function. First thing we're saying is, okay, return, so get me the length of X. That's going to be how many values are in X. And then print that. When we do that, we have 10, which is correct because that's the number of values we have in X. We can also pull specific values. So for here, we're going to pull, say, X, square parentheses, return the second value. Now that second value is actually 3. Python starts with that first one is actually 0. So it's the 0 placement is 1. The 1 placement is 2. The third place, 0 is 1, 1 is 2, 2 is 3, because it starts at 0. That's position 0, is the first one. If we do position 0, there's our 1. If we do :4, that's going to run everything up to the 4th position. If we do -2, we can also go backwards. So starting from 0, then there. We can also create a loop. So what we can do is we're actually going to create a basic loop that's going to go through each value in a list. So for X in range of 10, if X is 1, it's going to continue on. If X is greater than 5, it's going to break and stop, and then print X. Now these indents tell Python where to stop. So it's really important to have these indents here and the corresponding there too. Without those, Python wouldn't know where to stop and it's going to throw an error message. Now we can't just run line, line, line. We have to highlight this whole loop and then run it. It's return 0. 1, since 1 is here, if X is 1, continue, so it skipped it. 2, 3, 4, 5, and once it's greater than 5, it stops. Great. Now what we can also do is we can create a tuple. A tuple, or elements in a tuple are ordered just like a list, so it can be assessed by position. However, the elements and positions are locked, so we actually can't change these like we could change a list. Now the difference between a tuple and the list providing it is a tuple uses parentheses rather than square brackets. So we're going to create an immutable list, or a tuple, of B. We can do length of B, And we can also refer to position. What's the second position or third value, which is 3 here. We can also use strings or a series of characters. So I'm actually going to assign a string of characters. So it has double quotes to start and end. If you use double quotes, single quotes, it doesn't matter, but you have to be consistent. If you start with one, you have to end with it. So here we're creating an object called H saying hello Python or hello workshop attendees. And now we have an object H, it's a string, there's one value there. We can print H, and that's going to go ahead and print it out on our console. We're going to create an object called I saying having fun with Python yet. And all we can do is we can print parentheses H comma I, and that's going to print both objects together. So now we get hello workshop attendees having fun with Python yet. Great. So next thing we're going to do is we're going to cover dictionaries. A dictionary is really good for grouping elements. In this example, each group of elements starts with the group indicator, movie name, and episode number. This makes a dictionary a convenient way to construct a data frame in Python. So we're going to go ahead and create an empty dictionary called Star Wars, then use curly brackets. We've created a placeholder. Now what we're going to do is we're going to go ahead and create an entry within the dictionary. So we have Star Wars The Phantom Menace and saying it's equal to episode 1. I'm going to do that for each of the different episodes. And I'm going to press enter and I'm going to type in the newer movie. Let me go ahead and run that new entry there. So let's say we wanted to say, okay, with the title, A New Hope, give me what episode number it is. So I'm using a method called .get. I'm referring to our dictionary. So on this dictionary, use the get function and print out what corresponds to A New Hope. That's episode 4. I can also create a loop where for each episode in Star Wars, print episode with a colon plus square bracket episode. So when we do that, it's going to print out the title and the corresponding episode numbers. So we're going to stop this video here, and we're going to pick up with importing a data set. We'll see you in video 2.